Let's go over there.
Shawn Willsey, Skye Cooley. Let's go do it.
Okay.
Come on, man. This is great. Is this a well-known site, Shawn, or is your roadside geology book in Idaho the first time that this area has become well-known?
I think this site is known for the petrified trees, which are just up above us. But when I first came here, I was just expecting the petrified trees, not really sure if there was going to be much of a story here, much diversity, but I was blown away. I was utterly just giddy looking at this and interpreting this landscape, seeing the folds in the limestone, the unconformity, and this conglomerate were just like really icing on the cake for me.
Terrific. This episode brought to you by Hoka's. Hoka's,
Right.
in the big blue box. You gotta love it.
Hoka, if you want to sponsor some intrepid geologists in there.
Yeah, now wait a minute. How long has that taken to realize?
We'll have to send in an email.
What in the world? This is the most impressive conglomerate I think I've ever seen.
Really?
Well, have you seen a conglomerate with class that big?
Yes.
Where?
But they're still this impressive. So the Sevier Foreland Basin. So sediment shed off the Sevier Mountains into those proximal environments at the foot of the mountains. Echo Canyon in Utah. Down in central Utah, there's a place called Maple Canyon.
Holy shit.
And you see clasts that are
You've got to be
this
kidding
big.
me. Really?
And they're all quartzites.
Quartzites. I don't think there's any place in the Pacific Northwest like this. Maybe for the first time, I'm convinced I'm in the Rocky Mountains right now.
Well, I'm just glad I was able to impress you, Nick. So.
Well, and the beautiful look of this quartzite, I mean, we don't have to break it. This boulder's shattered in half.
Yeah.
And this crushed, dense, I mean, this is a bunch of quartz sand that got absolutely smushed. This has to be 1 billion years old, would you say? Is this part of the, I don't know.
Well, we do have some Precambrian quartzites, but locally here, our dominant quartzite is Ordovician in age. So we have some Ordovician age, lower Paleozoic quartzites. I think it's called the Kinnicknick quartzite.
Yeah.
And that would be the most likely source, although it could be from other places as well.
Wow.
You know what strikes me here is, these aren't really alluvial fans, and they certainly don't look like stream deposits. This is super proximal, hyper proximal to a fault.
To a fault.
To a fault.
So
look at how jumbled this is. There's no organization whatsoever.
Right.
There's a muddy matrix in here, the shattered clasts crushed together.
So go ahead, sorry, Nick.
So you're saying, Shawn, that anytime you're near one of these major thrust faults in the Rockies, you've got this apron of this kind of stuff very close by.
Yeah, I mean, anytime you have large mountains and a steep gradient, you can generate these high energy stream systems that can transport their load down to the base, and you'll end up with, the classic model is having conglomerates close to the mountains, and then as you move further away, that grades into more sandy type deposits and then muds. And certainly in the Utah-Wyoming thrust belt, you see that. You see proximal conglomerates, sandstones, then you head out into Wyoming, like Green River, Wyoming, and now you're in the more distal fine grain deposits.
And your muds are that distal fine grain, and this is part of either a lag deposit or part of the bedrock.
Yeah, could be lag deposits, right? So these are just maybe being incorporated, and they're already there on the landscape, and this got incorporated.
These could have been sitting around for tens of millions.
You got plenty of time between the Ordovician quartzites and this 50 million year old conglomerate.
That's a creative
But, I mean, that face across the way, it felt like we were walking up a faulted canyon here because the rocks just changed dramatically across.
But it continues over there.
And it continues above that. Yeah, but I mean, that's bedrock, or is that the conglomerate,
That's all conglomerate.
there? That is the
That
conglomerate.
outcrop is all conglomerate. And then you can trace it up to the right to that light brown unit, but then the gray just below it is the limestone. So that's your unconformity.
So there's some different facies in this conglomerate for sure.
Right.
We're in the course.
Yeah, because up there it's not nearly, I mean, there's basketball size class, but not these, meter plus size rounded gravels like we're seeing here.
So viewers, let me just try real quick and then Shawn can correct me a little bit. The general thing I think I'm hearing is that we have one major gap in the rock record. Everything below my hand goes back hundreds of millions of years ago. And everything above my hand is the Eocene, so it's younger than 50. And we change from these folded limestones to this incredibly thick, beautiful conglomerate. But the Eocene is not just conglomerate. There's all this other hell on wheels stuff going on. Magmas, volcanics, hot and humid plant fossils, what we're about to head to. Is that roughly the main story here, Shawn?
Yeah, that's the main story. And the conglomerate isn't even that thick. It's filling in the topography. We have this incredibly eroded and variable landscape as the Eocene dawns. Yeah. And that's the landscape upon which these conglomerates are filling the low spots. So kind of on this side of the creek where the conglomerate's quite thick going up the ridge, this was probably some lower topographic area. God. Looking back to across the canyon where you were looking at, you can actually see where that conglomerate at that unconformity, as you go up the ridge, up near the skyline, you get some more white, light gray units. Those are some of the volcanic tuffs. So the conglomerate's not that thick over there. It's maybe a few, tens of feet or so.
Love it. Thank you. Great first stop.
And then, how do you explain the big rounded class?
I think these are lag.
So they were already there, sitting out on the landscape, brought in by who knows what river system millions of years ago.
There's a real bimodal roundness here, right? There's these really rounded things, big and little, and then there's all these chunked up. Yeah,
I did see some of the muddy stuff you saw in there too. It's a weird conglomerate. It's not just sand and gravel. There's there's almost intact lenses of that more muddy stuff in there.
I think this whole pile's tilted too.
So you think it's more it's sort of in the fault zone?
I think you're right up against that fault zone. And that slick would tell you a little bit about that. Yeah. I think we're within from here to there away.
But if you went up that ridge, would you expect to see the mud's gone and it looks like a more normal conglomerate?
I would expect you to just lose a lot of your huge boulders.
Right. I mean, it is true that I've only seen boulders on this scale, right on this side of the wash.
Okay.
And as you go away from that, they're still impressive. They're, half meter, but they're not a meter and a half.
So it's a working hypothesis, whatever.
Yeah. No, it's all spitballing hypotheses.
Love it.
Ignimbrites are just, because they're smaller, I think, eruptive events. But maybe that suggests that this conglomerate, which has been lumped into the base of the Chalice volcanics, maybe it's considerably older or its own unit.
So there's a break between maybe that bottom part, or maybe this whole thing is...
Yeah, maybe a break between the conglomerate going into the volcanics of some time.
Well, certainly energetic to less so.
Right.
Yeah.
Right, but you've...
Basin filling, but...
You've created these volcanic vents that are just spewing out material all over the landscape.
And we're talking about what time again?
So 51, 52 for the initiation of it all, I think.
And yet the maximum global temperature time is 56 with that Paleocene, Eocene thermal maximum.
That's when it gets really warm?
I would want this petrified wood we're heading to be from that time. But
yeah. Generating natural gas.
So I think we want to actually go this way for just a short bit. Let me actually check the book.
These royal fills are even pretty impressive. 3 meters of a royal fill. It's like we need a guidebook for this.
What book are you using?
What did the author write?
Okay.
Yeah, there we go. So when the trail intersects the gulch, detour into the gulch for stop 2. I'm just not sure if I think it's this way actually. Let's go that way.
here's a modern debris flow, right? Similar to what we were looking at. So not as energetic.
Yeah, this is right up your alley. A little geomorph.
Pointless?
Oh,
No, not pointless. I think it's very interesting. We got to understand this to understand some of the other stuff.
pumice-rich Eocene volcanics.
Anesthetic. Okay. Still a little quartzite showing up.
Yeah,
Right
so the question would be what you guys think of this in terms of, is this
Right on top of the quartz, right on top of the
like
contact.
ash flow tough? Is it more lahar?
That's exactly right. Good. Yeah, this is embedded
Oh, is it?
in the...
Yeah, maybe. Big quartzite piece. Maybe
Yeah.
they are in there and I never noticed them.
Yeah, I thought that's what you're showing us here. That looks in place.
So it is, yeah. So these did sort of surround these quartzite clasts.
So we're above the
was erupting.
conglomerate now?
Yeah, we're above the conglomerate stratigraphically. We're near the base of the Chalice volcanics. And we
Well,
have
that would
these.
explain if we can find some quartzites in this
Yeah, absolutely.
stuff.
Yeah. I
Maybe
it's-
Skye Cooley could help you with that.
It's absolutely right. I mean, look at all that. Yeah. This whole stone line through here, this whole zone this is in place, surrounded by this gray volcanic. This is in place. All these are in place. Rip ups
Okay.
incorporated into this younger volcanic unit. What it means, I don't know, but that's definitely a look at that. The horizon just continues as rounded.
Or
Class.
this is truly the top of the conglomerate bedrock and everything is just falling on top of it. Do you think? Do we think it was the
I think what I
Probably
see here
moved.
is this brownish gray stuff above and brownish gray stuff below, and these
below?
older
Yeah.
stuff
Got it.
incorporated into
Got
the
it.
class.
Good
of the
eye.
older stuff.
Yeah, you're quick.
And see, these are sub-rounded.
Okay.
Yeah, there's just a little half a foot zone here.
All right.
All right, I got something good.
You wanna pick it up there? Nice.
You see these? Plants.
Awesome.
So in the middle of this dramatic volcanic swirling up with cobbles, we've got these delicate plant fossils?
Well, there's a bit of a contact here between this more fine-grained material that's hosting these plant fossils, all these dark zones. Here's some really great ones over here.
So that's like a lake bed,
Could be like a marsh.
a quiet leafy spot.
Right, so the Eocene was really moist, lots of plants. I mean, nothing like today. We're in this kind of sagebrush desert. And then we've got this sharp contact here into this ash-rich unit, this more explosive eruptive event. And so we're getting, I hadn't seen this before, this is actually pretty cool. Some of this plant material, some of the what was going on with the biologic activity at that time.
So you could see some imprints there, yeah.
Yeah, little stems and, I mean, I'm not a botanist, but
Seeds and stems?
yeah,
No,
little
that's something else.
needles of things maybe.
Yeah. Very Republic Graben-esque.
I mean, if you probably played with this for part of the day, you could maybe pull out some leaves.
Yeah.
That's nice.
These
there.
are great.
Here's some good ones here.
You think somebody, I mean, maybe you can't, but somebody could identify.
Someone could identify
Yeah.
maybe the material we're looking at, not me.
So this is akin to the big palm fronds, the same rough time frame as up in Washington, up to Bellingham Bay, all the way down to central Washington. It's the same hot, humid time here. In fact, it's the same hot, humid time over much of the planet.
Yeah, these are great.
Yeah, that's the idea. Just really warm, humid. And as we'll see, we'll get up to the sequoias, but this is the litter, right? The branches, the leaves, the needles. I mean, look at those. Just beautiful carbonization.
It's a bark and then like pieces of.
Yeah, just litter, like the kind of litter you'd see on a forest floor somewhere. Just
Spectacular.
twigs, leaves, yeah. Little calcite vein cutting through it right here.
So you were wondering if this was lahar or pyroclastic flow. This certainly doesn't look like lahar to me. I don't know about you guys, but this is so dense.
Yeah.
This is pumice rich, but I don't see anything indicating a
Right.
a flowing slurry of mud coming down a valley.
So up here I found pieces of like charcoal, and so I don't know if that moves that meter a little bit or not. I think it's up here in this left wall. We might see some more of that. But I'm glad we found that little plant horizon.
But lots of lithic fragments in that gray stuff.
Yeah.
Nick.
Yeah, like so it's got to be moving along the ground, probably.
So not just directly airfall, but some less energetic.
Right.
Why wouldn't this be a pyroclastic flow?
It could be.
Well, we wouldn't.
Yeah, here's your class
Chunks.
embedded in it, Skye. I don't know how.
Yeah, you get chunks of this
How I missed these
looking
before.
stuff or whatever it is. Yeah, that's that same horizon, I bet.
Right.
I bet it's associated with your fossiliferous unit. It's an old ground surface. Yeah, big chunks in this. So
Lots-
it's ripping
lots of-
up what it can find.
Lots of biotite in it.
Lots of imbrication with this sort of cryptic bedding. All these
In the quartzites?
in any of these chunks that are in here, they seem to be
Right.
floating. You know, lots
Yeah,
of
they are organized a little bit, aren't they?
parallelism. Yeah.
Well,
Yeah, because
here-
these elongate class, none of them are like counter to that kind of layering. They're kind
So
of
at
running
least
that way.
here.
Yeah, I don't know where I found. Trying to look for the little charcoal pieces I found there. I haven't seen any. Maybe we'll find some further up.
Well, the main reason I think I'm backing away from the Lahar thing is that we don't really have stratovolcanoes with these chalice magmas. It's a bimodal scene. We either have effusive basalt or we have these rhyolitic explosions. So why would we even be talking about Lahars?
Well, in my mind, the only thing you need to generate a lahar is topography, so steep topography, water, and it was a very wet time at that time. It doesn't have to be melting in ice, a glacier on the summit like a Mount Rainier type lahar. You can get lahars in Costa Rica at their volcanoes. So if you put a bunch of ash on the ground, let's say we have an eruption, we blanket the whole area with a foot or two of ash, and then we have, a long protracted rainstorm or heavy rainstorm event that mobilizes that ash and creates slurries moving down this high topography or high gradient landscape. That's a lahar. So you could maybe do that. You don't necessarily need ice and like the classic stratovolcano sort of model.
Okay.
I mean, when we get up to the trees are definitely in this stuff. And the
Okay.
trees definitely look like either flows or ashfall just blanketed them. They just were killed, right? They probably caught fire, who knows, incinerated and then buried.
Yeah.
But sheared off, right? Like there's the trunks, some of the trunks are pretty tall, like maybe 10 feet, but not like some longer, column of wood that's still preserved.
Awesome.
The petrified logs are in this.
Yeah, if not this specific unit, a similar one up
A
above.
light colored unit.
Yep.
Okay. Yeah. Well, you got the woody debris already. I mean, you've already introduced us to.
Yeah, those plants, I hadn't seen those before, so that was a fun little bonus to squat down and see some of those plant fossils.
So every little brown layer, I would be looking for plant
Right,
fossils.
those organics, right?
Yeah.
And then, so you kind of have these, layers, times when the volcanoes weren't erupting, and you're getting these fine-grained layers with the plant debris, and then you get a big explosive eruption that blankets the landscape, covers everything, and, kind of like, that's what's interesting to me is like, this is a landscape that the slate is being cleaned most likely with every eruption. You have this healthy forest, this vibrant ecosystem. Some of these big eruptions wipe everything out, kill the trees, decimate that ecosystem, and then you start fresh again.
And it's such a verdant landscape. It's just eager to grow back.
Right. It's like when you go to Hawaii, there's flows from like literally a year or two ago, but the ferns are coming up through them.
Yeah,
So
yeah.
like the plant succession is really rapid in these wet climates. So we go up a little further, then up the gully to the right is where we'll get into the trees.
So when I hear about Chalice volcanics, is this one of the major signatures of Chalice volcanics, or are there lots of basalt flows and rhyolite plugs and things of that nature?
Yeah, I'd say this is just one of several units we see in the Chalice volcanics. We get these more explosive, ash-rich layers like this one, and then in other places we get dark lava flows, andesites, basalt, maybe dacites, and then other ash deposits. So it's a real smorgasbord, a real mixture of different volcanic units. It's really diverse.
Are we inside or outside of the mapped caldera in the neighborhood?
There's a few calderas that are mapped to the north that are pretty significant and large. We're definitely outside of that here, but was that the source vent for this material? I'm not sure. All right, up to the forest. Yeah, so we have several of these fossilized Sequoia stumps across this hillside, and maybe more regionally preserved as well, but many of them sit at different levels or stratigraphic horizons, and so that speaks to the fact that we had eruptions that decimated the forest, buried these trees,
Wow.
and then the landscape recovered, new trees grew, another eruption came sometime later, took out that generation of forests, and that sort of cycle continued for some time. I think there's been mapped out on this hillside alone, something like maybe at least 24, maybe up to 30 or so individual forest horizons.
Buried forests, dozens of buried forests. I love it. And some of these trees are in a cage, but you've got one there that's not in a cage. Let's come down there and take a look at some detail. So you think they're all Sequoia?
Yeah, that's what they've been. I'm not a botanist, but people have looked at it. I think they're probably looking at the wood grain, maybe some of the textures, and then the size of these as well to kind of arrive at that conclusion.
And when were these trees alive?
So these are Eocene, so these would have been anywhere from 45 to 52 million years or so.
A million years ago.
So you can see one margin of it over there by my rock hammer. So you're standing on one side of the tree, and I'm over here 6-7 feet away on the other side. But here you can actually see the growth rings of the tree. Like if you were to chainsaw a tree and actually look at the individual growth rings.
So just for clarification, viewers, if you watch my channel, we talk about petrified logs that are 16 million years old in the Columbia River basalt lavas. This is 50
to 45
million years ago.
Right.
And these are not buried in basaltic lava like the flood basalts in Washington. These are encased within this volcaniclastic stuff, which has been viewed as volcanic lahar deposits.
Yeah, this one's interesting here because we can see one edge of it on this side over here by you, but the interior is filled in with the volcanic material. So that, I guess, maybe suggests that this was maybe already a dead stump on the landscape, hollowed out by decay potentially, and then you get this volcanic event not just covering it, but in this case, filling it in. So this one's a little bit unique because usually you see that fossilized wood, throughout the whole span of the stump.
I'm just shocked that the trees are still vertical, whether it's pyroclastic flow or lahar. You'd think there'd be momentum to just knock these things over and carry them down a drainage.
But they're really big. And so maybe the pyroclastic flows weren't that energetic. Maybe these are mostly ashfall deposits. So if you just bury it in falling ash, then you really don't have a lot of the energy to knock it over. And most of them are still standing, so it does speak to...
Most are still standing.
Mm-hmm. And maybe these were the biggest, you got a Sequoia forest. I imagine just like in most forests, you've got old growth, new growth, all sorts of sizes of trees. And these were pyroclastic flows, but the biggest ones like this were big enough and resisted enough that they didn't get toppled over and they withstood that volcanic event. And all the smaller ones were pushed over, perhaps.
And maybe a lot of chunks are laying in the stratigraphy, but they're being kind of parallel with the layering.
Yeah, and I have seen like horizontal logs in here as well, which are obviously smaller than these big ones.
Where else is there petrified wood in the world? I wonder if this is some of the oldest preserved petrified wood.
Oh no, so if you go down to like petrified forest in northern Arizona, southern Utah, those are Triassic, that's the Chinle Formation. So that would be rivers that were flowing out of West Texas across the Southwest towards the Paleo-Pacific. Those logs, those aren't upright, they're logs that were carried by river systems. They're in like a very fluvial sand gravel deposit, but those are 230 million years old. I don't know if one's older than that, especially in the West, because in the West you go older than the Triassic and everything's seafloor mostly.
I mean, isn't there Absaroka volcanics similar to this?
Yeah, same age. Yeah. So the stuff in Yellowstone, the forest, the petrified forest in Yellowstone is same age basically. So similar setting, similar climate.
Multi-tiered.
Yep. And stumps or logs. I don't know, some of them might be about this big. They're definitely in the same ballpark size-wise.